For centuries, we believed the universe was built from tiny, indivisible atoms, nature's ultimate building blocks. Everything, from trees to stars to ourselves, was just a different arrangement of these fundamental particles. This atomic model brought order to chaos, laying the foundation for modern chemistry and physics. Atoms were like universal bricks. Rearrange them, and you get everything from grains of sand to living cells. But as science advanced, cracks appeared in this simple picture. We discovered atoms themselves were made of protons, neutrons, and electrons. Then, even those particles were found to be made of quarks. The deeper we looked, the stranger things became. The universe was no longer a solid mechanical construction set, but something far more mysterious. The building blocks kept getting smaller, and the rules less intuitive. The simple clockwork universe of atoms dissolved, replaced by a reality that was subtle, dynamic, and endlessly fascinating. The story of what everything is made of was just beginning. Enter Michio Kaku, the renowned theoretical physicist and futurist, who urges us to abandon the old static image of the universe as a pile of inert bricks, lifeless, cold, and unchanging. He challenges us to let go of the notion that reality is simply a collection of objects passively existing in the void. Instead, Kaku invites us to reimagine reality as a grand cosmic symphony, an ever-evolving masterpiece, where every element plays a vital role in the unfolding of the universe. In this poetic vision, the universe isn't constructed like a building. It's performed like a piece of music, with each note and harmony resonating through the fabric of space and time. Particles such as electrons and quarks, which we once thought were the most fundamental building blocks, are not truly the most basic things. Rather, they are like notes in a cosmic melody, each with its own unique frequency and tone. Each particle is a specific vibration, a distinct pattern of energy rippling through the underlying fabric of reality, much like the strings of a violin or the surface of a pond responding to a gentle breeze. The universe, then, is the sum of all these vibrations, a beautiful ongoing piece of music with countless melodies and harmonies weaving together to create the cosmic whole. This idea echoes the ancient wisdom of Pythagoras, who believed that harmony and mathematics lie at the very heart of the cosmos, shaping everything from the motion of the planets to the structure of atoms. Today, modern physics reveals that the universe is governed by elegant mathematical laws, nature's own sheet music, written in the language of equations and patterns that describe everything from gravity to quantum mechanics. We are not just collections of atoms drifting through space. We are participants in this cosmic symphony woven into the music itself. Life's chemistry, from the spirals of DNA to the dance of molecules, is a melody within the greater symphony, adding new layers of complexity and beauty. Consciousness itself emerges as a new movement in this composition, a profound and mysterious theme, as the universe becomes aware of itself through us. We are not mere listeners to this cosmic music. We are the universe becoming aware of its own song, capable of reflecting on its beauty and meaning. This perspective transforms our existence from a random accident into an integral part of a vibrant, resonant reality, one in which we are both the audience and the performers in the greatest symphony of all. If particles are notes, what is the instrument? What is the underlying structure that gives rise to the symphony of the universe? String theory offers a radical answer, one that challenges our deepest intuitions about the fabric of reality. At the heart of existence, there are no tiny spheres or point-like particles, only unimaginably small one-dimensional loops of energy, called strings, vibrating in a hidden, multidimensional space. Everything you see, light, matter, even the space between, is made of these vibrating filaments. These strings are the most fundamental building blocks, weaving together the cosmic tapestry. Like a violin string, each vibration creates a different note. In the universe, each unique vibration gives rise to a different particle, with its own mass and charge. An electron is a string vibrating one way, a quark another, and each pattern of vibration determines the particle's identity and properties. A photon, the particle of light, is yet another vibration. The entire diversity of particles we observe is just the music of one fundamental string, playing an infinite variety of cosmic notes. In this view, the universe is not a collection of separate objects, but a grand interconnected symphony. The standard model, with its zoo of particles, is like a messy workshop filled with countless tools and parts. It works, but it's complicated and incomplete. String theory tidies it up. There is only one thing at the foundation, the string. All the complexity emerges from its simple, elegant vibrations. All the properties of particles, mass, charge, spin, are just different ways a string can vibrate, twist, and oscillate. Strings are not static things, but dynamic processes, pure energy in perpetual motion, never at rest, always resonating. The universe, then, is not made of matter in the traditional sense, but of music, vibrations and harmonies echoing through the fabric of space and time. The solidity of the world is an illusion born from the harmonious vibration of countless strings, each contributing to the grand composition of reality. In the end, reality is not a static thing, but pure, dynamic, resonant energy, an endless cosmic melody playing the song of existence. Why pursue string theory? What drives scientists to spend their lives unraveling its complexities? The answer is unification, the quest for a single explanation of everything. It's about finding a common thread that weaves through the fabric of the cosmos. Physics has always sought to unite separate phenomena. Newton unified gravity, showing that the same force that makes an apple fall also governs the motion of planets. Maxwell unified electricity and magnetism, revealing them as two aspects of a single force. Today we have four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces are described by two incompatible theories: general relativity for gravity and quantum mechanics for the rest. This incompatibility is a puzzle that physicists are eager to solve. Physicists seek a theory of everything, a single framework from which all laws emerge. This theory would bridge the gap between the macroscopic and the microscopic worlds. String theory is our best candidate. Unlike point particles, strings are loops, vibrating at different frequencies. These vibrations smooth out the mathematical problems that plague other theories, offering a more elegant solution. String theory naturally includes gravity. It doesn't need to be added as an afterthought. One vibration of the string is the graviton, the particle of gravity, seamlessly integrating it into the theory. It doesn't need to be added. It's already part of the music, part of the cosmic symphony. The quest for string theory is the quest for the ultimate harmony of the cosmos. It's about understanding the universe at its most fundamental level. If successful, it would unite all forces, providing a single coherent picture of the universe, and reveal the deepest simplicity beneath the universe's complexity. It would be a profound leap in our understanding. The Dream One equation, one song for all of reality, a melody that explains everything. This is the heart of the scientific journey. It's a quest for knowledge, for understanding, and for the ultimate truth. To appreciate the universe's symphony, we must enter the quantum world, the realm of the truly strange. Here, reality is a haze of probabilities, not certainties. Particles like electrons exist in many places at once, only settling when observed. This isn't just theory, it underpins lasers, smartphones, and nuclear energy. Even stranger is quantum entanglement. Two particles can be linked so that a change in one instantly affects the other, no matter the distance. This spooky action defies common sense but is a proven feature of our universe. Quantum mechanics reveals a universe that is deeply interconnected, not a collection of isolated objects. The separation we perceive is an illusion. Everything is entangled in a single quantum state. Like instruments in an orchestra, nothing exists in isolation. The quantum world shows us that the universe is built on profound, spooky interconnectedness. The quantum world isn't just strange, it's powerful. Classical computers use bits, zeros, or ones, but quantum computers use qubits, which can be both at once. This superposition gives quantum computers immense parallel processing power. They could solve problems in minutes that would take classical computers longer than the age of the universe. Quantum computers could revolutionize medicine, material science, and artificial intelligence. They might help us design new drugs, invent superconductors, and optimize complex systems. We are on the threshold of a new era, moving from digital to quantum, harnessing the music of the subatomic world. The future of technology is quantum. String theory's symphony requires more than the 4 dimensions we know. It predicts 10 or 11. These extra dimensions are curled up, invisible to us, but essential for the theory's harmony. Imagine a garden hose. From afar, it's a line. Up close, an ant sees another dimension around its surface. Our universe is like that hose. 3 large dimensions, with others hidden at every point. Strings vibrate, not just in our space, but through these hidden dimensions. This opens the door to the multiverse. Our universe may be just one bubble in a vast cosmic foam. Each universe could have different laws, constants, even dimensions. The quest for a theory of everything is a search for the principles that create universes themselves. We are exploring not just our universe, but the very fabric of existence. Understanding the universe's music isn't just for curiosity, it's the key to our future. Quantum computers could unlock clean fusion energy, ending our reliance on fossil fuels. In medicine, we could design drugs atom by atom, cure diseases at their source, and extend healthy lifespans. New materials could revolutionize technology, superconductors, space elevators, carbon recycling, but with great power comes great responsibility. The same physics that powers cities can create devastating weapons. Science is a double-edged sword. Wisdom must guide our discoveries. The future is not guaranteed. It's something we must build, thoughtfully and ethically. The technologies of tomorrow are born from the physics we discovered today. Our choices will shape the world to come. We stand at a remarkable moment in history, peering deeper into the universe than ever before. Our journey has taken us from thinking Earth was the center of everything to realizing we are part of a vast, expanding cosmos. Now we glimpse the music of vibrating strings at the heart of reality. This quest is driven by curiosity, a trait that defines us as human. Science is not just for experts, it's a way for all of us to explore the universe's mysteries. The cosmos is more magnificent and strange than our ancestors ever imagined. We are the universe's way of thinking about itself. Keep asking questions. Keep wondering. The story of the cosmos is still being written, and we are part of its song. We are made of star stuff, privileged to wonder about the stars.